So, good morning, children. So, for the today's class, we can discuss the continued topic, that is types of interrupt service routine, and how to handle the interrupts in 8086. So, first of all, we can discuss about what is interrupts. So, interrupts is nothing but it is an some event that breaks the sequence of operation. For example, if you're executing instruction and suppose any externally or internally any interrupt is being fed, that is fed, so that execution will be stopped and the CPU start executing the interrupt. Okay. So interrupt is some event that breaks a sequence of operation. So if an interrupt occurs, what happens is that it first breaks the normal sequence of operation. That is, if the CPU is executing some sort of instruction, when the interrupt occurs, it breaks the normal sequence of that particular execution of instruction. Then this interrupt, this event, that is the interrupt execution will be diverted to some other program called as interrupt service routine. Okay, that means interrupt service routine is nothing but ISR. It's a form of program where the interrupt is being diverted. So after executing this interrupt service routine, the control is again transferred back to the main program where which was being executed at the time of interruption. Okay. So what is happening? First, when a normal instructions are being executed by the CPU, when an interrupt occurs, that interrupt will be diverted to an interrupt service routine. Then after executing that interrupt service routine, again the control is being transferred to the main program which was being executed at the time of interruption. Okay. Now, suppose many interrupts are being many if suppose many interrupts gets uh, interrupted. So what happens is that the processor will handle those interrupts. So it is the ability of that particular processors to properly handle those interrupts from a number of devices. If there are multiple interrupts are coming, then the processor has an ability to process all those multiple interrupts. That we call it as multiple interrupt processing capability. Okay. And in 8086, there are two interrupt pins. One is NMI and another one is INTR. So NMI we had discussed earlier, it is a non-maskable interrupt. If that particular interrupt occurs, the CPU or the processor it can't ignore that type of interrupt. That type of interrupt is called as non-maskable interrupt. It cannot be masked, and that type of interrupt occurs. The CPU can't ignore those types of interrupts. Because of that only, the name is as non-maskable interrupt. And another one is INTR. It is an interrupt input pin, and it may be masked using interrupt flag. Okay, so it can be accepted or it can be accepted by the CPU. So this INTR has of 256 types of interrupts, 256 types ranging from 0 to FFH in hexadecimal. So when an external program interrupt controller, that is an external program interrupt controller, is used to handle that type of interrupts. Now, interrupt service routines, that is ISR, it is It is the programs which are being executed by the interrupting the main program execution of the CPU after an interrupt request appears. As I have told earlier, when an interrupt occurs, that pro- interrupt is being diverted to some other program that, that we called as interrupt service routines. So it is being executed by the interrupting the main program execution of the CPU. Now, after the execution of that ISR, the main program continues its execution further from the point at which it was interrupted. Now, what are the two types of interrupts? The two types of interrupts are external interrupt and one the internal interrupt. So what is by external interrupt? The external interrupt is nothing but it is the interrupt coming from an external device. That is, an external device or a signal interrupts a processor from the outside. For example, a keyboard interrupt. An internal interrupt is nothing but generated internally by the processor. For example, if any operation is being executed like divide by 0 means it is type of an interrupt. Of course, an overflow interrupt. These are all internal interrupt. Okay. So, now let us discuss about interrupt cycle of 8086. So, as I have told earlier, when an instruction is being executed by the CPU, suppose an interrupt occurs, what is done is the CPU first complete the execution of the current instruction. If this current instruction is being executed, then instruction pointer, what is the main function of the instruction pointer? The instruction pointer which points to the next instruction to be executed, right? So same it is done here. First the CPU executes the current instruction, then the instruction pointer is being incremented to the next instruction. Then the CPU acknowledges the requesting device. That is, if an interrupt occurs, the CPU acknowledges that interrupt request. So that interrupt request when by so in the acknowledgement process, the CPU checks the IF flag. IF flag means interrupt flag. If the interrupt flag is set to 1, that means the interrupt request is being acknowledged by the processor. And if the interrupt flag is 0, then the interrupt request is being ignored by the CPU. Once the interrupt is being acknowledged by the CPU, CPU computes the vector address of that particular interrupt. Okay, if the acknowledgement is being accepted by the CPU, then it computes the interrupts will be having a vector addresses, and that vector addresses will be computed by the CPU. Okay, and the contents of instruction pointer and CS are being pushed to the stack. That is, after calculating the vector address, the IP and CS are being pushed to the stack. And also, processor status word, the current execution of particular operation is being stored in a processor status word. It is also pushed to the stack and the interrupt flag is cleared after the acknowledgement. Then what happens is that this control will be transferred to the ISR to execute the interrupt. Okay, so after the control is being transferred to the ISR, the new address of the ISR is found out from the interrupt vector table. Okay, the addresses are being found from the interrupt vector table. It's a form of table where the addresses of different interrupts are being stored. Then the execution of this interrupt service routines starts. Suppose if further interrupts are also being responded to the during the time of first interrupt, again the IF flag will be set to 1. Okay, and the program interrupt controller is used to manage such type of multiple interrupt based on their priorities. So, what is an address of an ISR? Address of ISR means interrupt service routine. As I have told earlier, we have to calculate the vector address of that particular interrupt, and these vector addresses will be stored in a vector table. Okay, so this Intel has reserved about 1024 location for storing the address of ISR, and each interrupts will require 4 bytes. That is 2 bytes for the instruction pointer and 2 bytes for the CS. Total there are 256 interrupts, and for each interrupt it will be storing 4 bytes of data. That for and which computes to total of 1024 bytes are required for 256 interrupts starting from 0 to 3FFFH. So this interrupt vector table, it contains an instruction pointer and CS register for all types of interrupts. Total of 1024 bytes. And these interrupt type, then how to calculate these address? First, that interrupt, there are different types of interrupt. If there are n type of interrupts, that n is multiplied by the 4 and the hexadecimal, and that hexadecimal multiplication gives us an offset address in CS, where the IPN at which the IPN CS address of the instruction pointer are stored. This is how we calculate the address, interrupt address. That is, if it is an interrupt type n, that is multiplied by 4 and the hexadecimal multiplication gives the offset address in CS at which the instruction pointer and CS addresses of the instruction service routine are stored, and the execution will start from that CS IP. Okay, so there are different types of types of interrupts. The 5 dedicated interrupts are type 0, type 1, type 2, type 3 and type 4. Type 0 is the divide by 0 interrupt. As I have already told, it is a type of internal interrupt, that is divide by 0. If there is any division is in the instruction, like if the divisor is 0, automatically that interrupt occurs. In a single step interrupt, that is INT1, executes the microprocessor executes this interrupts after every instruction if the trap flag is set. If the trap flag is set, automatically this interrupt starts executing. And type 2 is a non-maskable interrupt, is an NMI. NMI, it is the highest priority. It can't be ignored by the processor. Of course, it should be executed by the processor at any cost. Okay. Now, type 3 is the 1 byte interrupt. It is being invoked by a special form of software interrupt instruction which requires a single byte of code. And this interrupt is primarily used as breakpoint interrupt for software debug. And last one is the type 4. It is a dedicated 5 interrupts, and in that the last one is the type 4, which is called as interrupt on overflow. Whenever an overflow occurs, then that type of interrupt occurs. The interrupt occurs if the overflow flag is set if in the flag register. Okay, so these are about today's class. Thank you.